Okay, I'm going to be talking about DS9. DS9 is an application for visualization of astrophysical data. So I'm going to go ahead and share my screen and let's see what we got here. Okay, here we go. Okay. So first of all, where do you find DS9? So this is the DS9 web page. Okay. At the DS9 web page, you can find information about documentation. You can download current binaries. We support over 20 different platforms right now. And then the last page is a gallery or examples of some of the lessons or exercises I'll be going over today. I've also put on the website copies of my slides and the data that's going to be used in the examples. You're welcome to go to this website and download them. I have them as tarballs, or also you can go into each file and download the data directly. So what exactly is DS9? First of all, DS9 is not Photoshop or GIMP. Photoshop and GIMP are image processing, applications for processing image data. DS9, on the other hand, takes astrophysical data, or one value per pixel, and turns it into an image, or 3 values per pixel. So, say for example, on the Chandra X-ray satellite, the instrument receives an X-ray energy photon. It impacts on the instrument, the ACES instrument, and builds up a charge well, and that gets dumped. There's a floating point value at that time recorded for that location on the instrument. DS9 will then take all those one floating point value per pixel and allow you to map colors to it so you can visualize it. So again, the important point I would like to emphasize is DS9 is not Photoshop. You use DS9 to translate astrophysical data into an image that you can then feed into Photoshop. So how does DS9 map this data from one value to 3 values? So basically, you as the user easily tell DS9 what kind of scale distribution you wish, the region of distribution, what kind of false color scale you wish to apply, and then how you would like to just distribute the colors on that color scale. And I can go into this a lot more detail later if you wish. But for now, we'll just say it allows the user an immense flexibility on mapping that one value to 3 values. So I'm going to go through 5 different exercises or lessons on using some of the advanced features of DS9. So the first exercise is just some basics, okay? Now I'm using version 8.2, which we just released a few months ago, and we will be having an update 8.2.1, hopefully in another month or so. So the first item I'd like to draw to your attention is the use of themes or dark mode. Apple macOS came out with dark mode a couple years ago, and everybody loves it. So we have now implemented dark mode for Linux users and Windows users. The way you change your theme is you go to Edit, Preferences, and here you have your themes. So this is the default. This is the dark theme. Here we have a something that someone on Ubuntu, GNOME would recognize. These are kind of my favorites. They're more of a straight, no fuss, but yet elegant theme. Anyways, basically, you get to choose how you want your colors, your fonts, your windows to appear to you. And this is really useful, especially if you're observing at night or you're working at night. This is so much easier on the eyes. So once you pick your theme, you hit save and you're done. Okay, so I'm going to go back to default here. Okay, second, we have a new feature for exploring FITS files. Now, a FITS file can be very simple in structure or it can be very complex. A FITS file can store an image, it can store a table, it can store a data cube. In addition to the actual data, it actually stores metadata in terms of headers, keywords, and header values. So it can get very confusing exactly what you have in your FITS file. Just to remind everybody, FITS file is a archive format. It is not an image format. PNG, TIFF, JPEG, these are image formats. FITS is an archival format. It saves one pixel, one value. So in this particular case, I have a FITS binary table. So this contains two sections. The first section is empty. The second section contains my table data that DS9 then is able to construct an image from. So to analyze this structure, we go to Prism. That's under File, Prism. So now you can see this particular file actually has 1, 2, 3, 4, 5, 6, 7 different sections. Each contains important information. In this particular file, this is actually from Roset, I believe. So this is a bin table of X-ray data. And this table here, this table labeled standard events, this contains data that was recorded on the instrument at the time, and then DS9 can then create an image from this data. So just letting you know, so when you have a FITS file and you want to know what's really in there, besides image or something else, go to File, Prism, okay? Okay, most people are familiar with DS9 as a GUI-based program. You click on buttons, you click on menus, you select things, you move things around. You can also drive DS9 through the command line, through something we call XBA, which is a communications protocol package, and also through SAMP. So I'm going to give you some examples of how DS9 can be driven or commanded to do things through the command line, okay? So for example, here's a simple command line. So what I'm doing is cranking up DS9. Let me make it more a little bit obvious. Cranking up DS9, telling it to load a file. I want to change the zoom value. I want to load a catalog, and I want to load a symbol table to change the appearance of that catalog. So now DS9 has gone through each command in line, executed that command. It waits till this command is done before it goes to the next. And then therefore, when it's finished doing all the commands, it stops and waits for you to take over, okay? Now here's the exact same thing using XPA. So basically it's just a series of commands. They're identical in syntax to the command line, but in this case, is using XPA to send the command to DS9. The advantage of XPA is you can send commands through the net. In other words, like I can actually have a remote DS9 running halfway around the world, and I can send individual commands to that DS9 through XPA. So this is, here's an example of XPA running. So again, it just goes through and executes each command in order until it's done. So this way, when you're processing a lot of data, you're not constantly having to do this by hand. You set up your little scripts, either on the command line or through XPA or through SAMP, and then let the shell handle all the work. Okay, one other final feature I want to, let me go back real briefly. And the rest of the lessons, I have displayed, or I have put in the archive, both the command lines and the XPA commands to do exactly what I'll be doing with the GUI. So you can look, that's a good place to look for if you want some examples on how to use this. That brings up a good point. How do you get help when you're DS9? DS9 is pretty involved. So here's your help button right here. Here's your reference manual. Here's your command lines. These are all the commands for command lines. Here's all the commands for XPA, the same titles, the same name. And here's all the commands for SAMP. Again, the same thing over and over. So whether you're driving this through the command line or through XPA or through SAMP, you have the option of having your shell or your Python scripts do all the work for you. You don't have to do this all by hand. Okay, one last feature that most people are probably not aware of is here you are in DS9. You've loaded your image. You loaded your data. You've been working on this for days, and it's just like you want it. And then there's a power outage, and it goes, and you lost everything. Okay, so DS9 has a built-in backup and restore feature. What this does is when you back up, it creates a snapshot of exactly what's on the screen, all the data and all the commands to recreate this, and stores it in a backup save set. Then at a later date, you can come along and restore exactly what it was at that time. So let me show you an example here. I'm just going to use this one right here. Okay, so I have a catalog, I have an image. Let's turn on some coordinate grids. And, for grins and jollies, let's do some contours. Okay, lots of data. Okay, so to make a backup, you go File, Backup, give it a name. In this case, I've already done this once, so I'm using the same name. Now it has made this snapshot of exactly what's on your screen. So now at a later date, you can go DS9, File, Restore, select your backup save set, and now it has reproduced exactly what you had at the time you made the backup. So people use this two different ways. Some people make lots of different save sets. One for Monday, one for Tuesday, one for Wednesday. Other people they continue to save into the same save set over and over, updating it. You can work it either way. It works fine both ways, however you want to run your archiving service. So just keep in mind that use the backup and restore to save yourself a lot of grief should something happen to all the work you've been doing at a previous date. Okay, so let's move on to some more fun stuff. Okay, fun with catalogs. Okay, so in this lesson or exercise, what we're going to do is we're going to load an image and we're going to play with it, make it pretty. We're going to load a Simbad catalog, and then based on the data in the SIMBAD catalog, we're going to create a color magnitude diagram. Now, SIMBAD is one of my favorite catalogs because it contains a lot of post-processing astrophysical data that you can use. Okay, and in particular, it has flux on B and V. So that's what we're going to use to create this color magnitude diagram. Okay, so here we go. So we're going to open up our data file. In this particular case, it's the Pleiades. And then we're going to go under Analysis, Catalogs, Database, SIMBAD, to go out and fetch catalog information for just the objects in this particular image. Not the whole world, just this particular image. Okay, so now we have 759 objects within this particular image. Okay, well, let's see exactly what we got. So we're going to go zoom to fit. So there they are. Now we're going to create a plot. So from our catalog window, we go plot. And we want to create our color magnitude diagram, we're going to do B minus V for the x-axis and V for the y-axis. So up here I go, let's see, we got B, there's flux B minus $flux V and versus V. So when you're creating plots from the catalog dialog to reference a column, it has to be exactly as it is in the column name. In this particular case, it's all caps underscore something, okay? And then put a $sign in front, the tail DS9. This is a column. Okay, so now I've created my plot, but it's not particularly attractive. So first thing I'm going to do is I'm going to flip Y, and then I'm going to change some ranges. So we're going to go from -0.2 to 1.4 on the X, and I'm going to go from 2 to 14 on the Y. And there we have a color magnitude diagram for the Pleiades cluster. If you look at, I've downloaded a similar diagram from one of my astrophysical books, and it's a pretty good match. You can see there's a couple of outliers that are not included in the original set, but yeah, it looks pretty good. Now, one feature that you can take advantage of with dialogues is, okay, what is this? Okay, so we go into pointer mode and edit catalog, and now when I click here, it highlights it on the image, and it highlights it in the the catalog tabulation. What about this guy right here? Well, he's way over there. And what about this outlier here? Well, he's over there. Same as with the plot. You can click on a particular column of your catalog, and DS9 will take you to that particular item on the image and bring it to your attention. And then finally, on the image itself, who is this guy? Again, it will highlight it in the image on the plot, and also in the catalog. Okay. So far, so good, I hope. Okay. Please let me know if we're moving too fast or too slow, or if you have any questions, feel free to raise your hand, okay? Okay, next, going on. Creating RGB images. Okay, up until now, we've been creating false color images. We take that one number, we create 3 values, RGB, by applying a color map, okay? RGB images are a little different. What we're doing here is something similar to like a Photoshop, where we have 3 different layers, one for the red, one for the green, one for the blue. We load up an image in the red, we load up an image in the green, we load up an image in the blue, and DS9 lays them or registers them based on their world coordinate system. And then you adjust until you have the image you're looking for. So here's an example. Okay, so DS9. Okay, now we're going to create a special frame to create our RGB image. Frame, new frame RGB. Notice how the color table now has changed. It's no longer an arbitrary color table. It's set to 3 layers, red, green, and blue. And this little box, this little dialog, tells us which is our current displayed, our current layer and what is being displayed. So right now, I'm going to go ahead and I'm going to load our first image. And it's going to be this one right here. And there's just nothing there. But yet, when I change the scale, now we see something. Okay, looking better. Okay, let's go on to the green layer. And again, I'm going to load a different file. By the way, this is all infrared data or near infrared data from IRAS or IPAC. And then again, we need to change its scale so we can see that, because currently we're still the green layer. Now let's change the blue layer. I'm going to load our last one. Okay, and again, we need to change the scale on that. Okay, now it looks like we got something here. So let's go ahead and let's rotate and let's zoom to fit. Voila. So this is the Eagle Nebula, if you don't recognize it, or M16. And these are the, I think they call them the pillars of creation. So this is near infrared data. I am incorrect. I believe this did come from Space Telescope and not IPAC. And this definitely looks like almost WIPPIC data. Anyways, so here we have 3 different images, different wavelengths. We put them into 3 separate layers, red, green, blue, and then combine them to create an RGB image. If you want to just see what the red layer looks like, so here's the red layer, and here's what the green layer looks like, and here's what the blue layer looks like. Oops, let me turn that off. Here we go. Okay, but when you combine all of them, so now I can adjust just the blue layer, I can adjust just the green layer, or I can adjust the red layer. Now, sometimes when the data comes from the same instruments, just different wavelengths, they all have the same properties. And instead of having to adjust each layer all the time, you can lock your layers. And that's what this is doing. So I'm going to lock the color bar. So now when I adjust the color bar, all 3 layers change at the same time. Okay. More fun. Okay. IFU data. IFU data is becoming really, really big business now. For people that are not familiar with IFU data is basically a tiny little image taken at slightly different frequencies, hundreds or thousands of them. So you have maybe a 128 by 128 by 4,000. So these data cubes are tiny pencils of data, and they're really, really hard to visualize. So in this particular case, whoops. Okay, so we're going to crank up DS9. We're going to load our data. Okay, so this is a data cube. See, here's slice number 1, and way over to slice number 6700. You'll notice in this window, this number changes. This is the wavelength. World coordinate systems can be more than 2 dimensions. In this particular case, the world coordinate system is RA, DEC, and wavelength. So this is the wavelength being displayed, I assume, in angstroms. Okay, so let's make this a little bit more visible. Okay, so let's first zoom. You notice that I go back and forth between the button bars and the menus. The button bars are a subset of the menus. You can actually customize your button bar by going to Edit, Preferences, and go to Menus and Buttons, okay? So in this particular case, the default button bar is usually the most popular menu items. You will find it much more easier to use the button bar than constantly going for menus, especially under Mac OS, where you're constantly having to go up, up, up all the time. So just keep in mind that you can either do everything I'm doing through the button bar or through the menus. Okay, back to the regular schedule program. Okay, so now we want to set the zoom to 4. And now we can see a little bit better. Again, you notice that basically we got a lot of garbage at the front. And then it's pretty constant all through, maybe a little blip in the middle, but we can't really tell what's going on. And then nothing, garbage. Okay, so we need to do some more work on this. Okay, so first thing I'm going to do is I'm going to set my scale to global. By default, DS9 dealing with data cubes, each slice has its own image dynamics. When you go set it to global and not local, then DS9 takes the whole data cube as a whole when trying to figure out how to display each slice. So now each slice is being displayed on an equal basis. So now we got still pretty much nothing. Okay, so let's go ahead and turn on Z scale. Okay, that helped a little. Again, a little blurb here and there. We got garbage at the front, garbage at the back. I'm going to try to adjust the color a little bit more so we can get a little bit more contrast. Okay, looking better, but yeah, look, it's got some blips here or there. Definitely something is in there, but we need to take a look a little bit more. Okay, so I'm going to put DS9 into region edit mode, and I'm going to create a region at the middle. This is a circle region. You can double click on that circle region and bring up that circles dialog box. And under the analysis is plot 3D. So what this does, it takes all the values in the circle for each slice, sums them up, and that's your data point for that slice. So essentially it's a projection down the third axis in this particular case in wavelength, and then you're essentially getting a spectrum. So this definitely looks like a spectrum. Looks like we got some emission lines and some absorption lines. And it looks like the strongest emission line is right up in here. So let me pull up my cube so we can overlook. So as I'm dragging the cursor, you can see that we're being updated. So it looks like our strongest emissions are around, call it 6,777 angstroms. I assume. I'm not sure on that. You'll have to look at the header of the file to see what the units are. Let's see what we got here. I'm not sure. Anyways, so we essentially use this data cube to extract a spectrum from the data directly. Now, it just so happens that I have already done that from another source. And there we are. So essentially, here's this particular data cube came from SDSS, and here is a spectrum of it, and that emission line is H alpha, and it's definitely around exactly where we said it would be. Okay, so you can use this feature of creating regions on your data cube and extracting 3D data from it. And it doesn't have to be a circle. We can change the shape to, say, an ellipse. And now it's a sum of all the data in the ellipse. Or you can also create histograms. So you have all these, each of the regions of interest that you can create and manipulate on DS9 has built-in analysis support for simple things. Going down plotting down the third axis of a data cube, creating a histogram from the enclosed data. Statistics, for example, if you wanted the, what are the statistics of that particular ellipse on that particular slide. Now, as I change the current slide slice number, the statistics change, the histogram changes. Of course, the spectrum will not. So this just gives you a feel for some of the things you can do with direct analysis from your FITS file within DS9. Okay, last example, last lesson. This is the fun one. Okay, in addition to supporting false color frames and RGB frames, DS9 will allow you to render 3D frames. Okay, so we go DS9. We go and frame a 3D frame. So notice this box comes up, this dialog comes up. This is how you control where your viewpoint is when examining your 3D data. Now we're going to go ahead and we're going to load the same data cube. Okay, and we're facing it face on. So now as I change the viewpoint, you get this long, thin data cube, tiny little slice, 120, I think this is, let's see what it is. It is 72 by 72 by 6,700 slices. And if we zoom out, you can see it's very, very thin, very, very long. And we change the scale, we can try to see what's in it, you know, not too good, a lot of junk. It looks like there's something right up in here. Let's go examine that, okay? So I'm gonna set my viewpoint to 45, 30, just so I can have a steady viewpoint. Then I'm gonna crop this particular data cube for just a few slices, just in this region here. So I've already worked out where that region is by just sliding the slider up and down. So you can see here's a slider right here. So I can tell it's already, you know, that's a good starting point and there's a good stopping point. So let's go with 6650, and this is in WCS, third axis WCS, the wavelength, and 6900. Okay, and I apply. So now we just cropped to just this little portion of the data cube. The rest of it we don't care about. So now let's center the image and let's zoom in. Okay, so we see there, here's our line, and then here's where we're getting a lot of emissions here. This is where we're really interested in. Okay, so what we're going to do now is we're going to apply a different color map to it. Just try heat. That looks pretty good. Adjust the colors a little bit. Yeah, let's go with that. And now what we're going to do is we're going to make a movie. We're gonna spin this cube around and save it as a GIF that can be replayed in a web browser or on your website. So to make a movie, we go File, Create Movie. This is going to be a 3D movie. Let's call it DS9 GIF because I've already done this once before. Okay, let's make it 30 frames. Azimuth, let's say from minus 180 degrees to positive 180 degrees. Let's keep our elevation at 30. So basically we're just spinning it a full revolution in azimuth. We're going to keep it at the same slice and we're going to keep it at the same zoom. Okay, so now DS9 is now rendering these images, saving them, and building up a animated GIF for you right now, and putting it in the file you specified. Okay, we're done. So now, if we go to the file we're looking at, and here it is right here, and I'm going to open it up in Safari, and there we go. So there is our animated GIF. And you will notice how the emission slices are quantized between the two, how to describe this? Even though there is actual data in between these two visual slices, for some reason, systematic or not, those emissions were not captured. So this is a very interesting data file in that respect. So, okay. So I pretty much concluded my set talk on what some of the advanced features I would like to discuss. And just on time, actually, we're right on schedule. So I think right now would be a good time to open the panel up for any questions or discussions or any input from you. So thank you so much. I hope this has been a help to you.